So in last session we have seen assembly basics, and now we will start with some examples of assemblies. For that I am going to assemble a butterfly wall assembly. So we'll start with the parts, calling with the first part. For that I'll say insert components, browse, and in browse I'll go for the folder in which I have saved the files for butterfly wall assembly. So in assemblies here I have this folder. I'll go for butterfly wall assembly here, and we'll start with the main body first. So we'll call first part as a main body. Select the part and say open part. And now this is the first part of assembly. So we'll first right click the part and then say float in condition. After making the part float, we'll go for the first mate, that is assembly's origin with first part origin, so as to combine all the center planes. For that I'll select assembly's origin and the first part's origin here. Now both the origins are being coincided here by applying coincide mate. It is done because all the planes of assemblies and first part will combine together. Next part we will call here is shaft. So for that insert components and browse. For that I'll call this shaft as the second part here. Now you can see the cross section of the shaft is circular. We have to insert in this slot here, circular slot. For that I'll again go for concentric mate. Whenever shaft and hole are given there, to assemble we have to go with concentricity. For that I'll select the mate command, select the circular face, and again go for the second circular face here. Say them concentric. I'll not lock the rotation this time. I want to keep it moving here. I'll say it OK first. Again OK. We can see here this shaft is rotating here as we have not locked the concentricity. Next I want this circular face of the shaft to be coincided with internal circular face of this body. For that again we will go for mates option. Select this face and the internal circular face of the main body and say OK. You can see here the movement of the shaft. And we'll go for the next part now, that is insert components again. Say browse and say retainer plate. Next select mate. We will say coincide of these faces. Again say OK. And we have to match the holes now. For that we will say concentric mate here. Now still these upper bolting holes are not matched. For that we'll go for concentricity again. So we are giving here 2 times concentricity so as to match all the holes, the center hole and the side holes. Again we will go for concentricity. Select both the circular faces for bolting, and now this part is fixed. We'll call the next part here, that will be the screw. Say it OK, open, and now we'll apply the screws here. We'll apply only one screw and then make pattern of that screw. For that select the bait option here. This circular shaft and circular hole, means by default it will take concentricity here as both the parts are circular. We have to flip the orientation of the screw. For that I'll select the mates for the screw, that was concentric mate, and then select the edit feature for that concentric mate, and we will orient the part by mate alignment. Now the orientation is flipped. Say it OK. As we have flipped the orientation, I'll continue with mates, making it coincide with the circular face. Say it OK. Now to lock the circular movement of the screw, we have 2 options here. That is, first one is making this flat face of screw parallel with the upper face. By default it will take parallel mate here. As this flat face of screw is parallel with the upper face of this body, the movement of rotation is locked here. Say it OK. Now we can see it is not moving or rotating here. Next option we will see, that is locking the concentricity. For that I'll undo this made here, and now right click on the part, and suppose if you want to see the specific mates of this particular part only, then just select the part, right click the part, and here you have the options view mates. Now this option will show only the particular mates of that single part only. Here if you see the mates, here it will show all the applied mate for all parts. But if I go for this option, right clicking and then viewing the mates, it will show only the mates of that particular part. So in concentricity, I'll right click and say lock rotation. So this is the second option to lock the rotation. It will randomly lock the rotation of the screw. It will not take any references of the faces here. Now this was the second option to lock this rotation. First one was making this face parallel to the upper face. Second was to lock the concentricity. Now I'll make the pattern of the screws here. For that we have linear component pattern option given. In that linear component pattern we'll go for second option, that is circular component pattern. As these holes are given in a circular PCD, pitch circle diameter, for that we'll go for circular component pattern. Select the option. In direction it is same as circular pattern in part molding only. So we'll select the circular edge here. So the linear and circular patterns are same as part molding circular patterns and linear patterns. You just need to select the direction box here. First you have to click in this box. Then for direction I'll select the circular edge as it is a circular pattern. If it is a linear pattern then I'll go for linear edges. Next, components to pattern. I'll show the screw here and then apply the number of entities you require to pattern. I'll say it 3. Say it OK here. Make this option equal spacing only. Now these screws are being patterned here. But you have to make sure before pattern that the first part which are you going to pattern, it is compulsory constraint. Then only make a pattern of that part. If you don't lock this part by constraints, if there is any movement remaining in the part, it will be carry forwarded in patterns also. That's why you have to make sure that part is fully constrained and then only you have to pattern the parts. So now this pattern is completed. We'll go for the next part. Select the insert components option. Say browse, and now we will call the arm here. I'll make this arm concentric with the shaft here. Say it OK. Now make the back face of this arm coincide with this face. First we need to select the mate option and then go for the selections. Now this is coincided with the back face there. You can see the rotation of this arm. Next part we are going to insert here is the nut. And now I'll make concentricity here with same shaft. I'll flip the orientation of the nut. Say it OK. Again OK. Then we'll select the mate option and go for coincide mate for the nut with the arm. Say it OK. Now to lock this rotation, I'll make this mate, that is the upper face of this nut parallel with the upper face of the main body. You just need to select two faces. System will by default take the parallel mate here. Say it OK. Now this nut is also fixed here. We'll call for the next part, the last part, that is this plate, elliptical plate. So for this elliptical plate, we'll make concentric mates first. We have to assemble this plate on this shaft here. So now these two holes will match the shaft two holes here. For that select the mate option and then select the concentricity between first hole of plate and first hole of shaft. Say it OK. This plate is underlying. We'll pick up the plate here. First say it OK and then drag this at upper side. Next we'll match the other hole. For that select the mate option. Select both the holes to be concentric. Say it OK. We'll rotate this shaft little bit. Again say it OK. Bring this plate at upper side and then go for the mate of this bottom face of the plate and upper face of the shaft. Again say it OK. Now you can see here this plate is being merged and being flushed by this part. Means this plate and part are being flushed here. This plate is intersecting this part. So we need to change the dimension either of the main body or of the plate here. We'll see the plate's dimension first. We'll double click on the part. And as it is a elliptical plate, there are two radius been given here. So the bigger diameter of the elliptical plate will be 205 mm. And now we will see the hole size of this main body. So the diameter for that is coming as 194. Now the biggest diameter here is 205 and here the diameter is showing 194. That's why this part is being flushed in this body. So to avoid this we have to make change in this body here. For that I'll select the body and say open part. It will be redirected in part molding here. You can see the model tree for the particular part. Now we'll change the diameter of this boss extrude. The internal diameter. Double click on the part. And here instead of giving 194 size, I'll go for 205.5. I'll keep 0.5 mm clearance. Again rebuild the part so as to update the part. Now the size has been updated here. We'll make Ctrl S and save the part and then close the part. It will be updated in the assembly also. Now you can see the edges are being shown. It means the intersection of this part has been avoided here. Now I'll make one more mate here. For that I'll go for lock mate. We have seen lock mate in assembly features. We'll select the lock mate. I'll select the upper face of this plate, elliptical plate, and this face of the shaft. Say it OK. And now as we rotate the handle here, the elliptical plate inside the main body is also rotated there. This assembly would look better if you apply appearance for each part or any material for each part. So before assembling, it is better to apply the appearances for different parts and then assemble the parts. So here the assembly has been completed now. So this was butterfly wall assembly, the first example of assembly for standard mates. So the second assembly we are going to see here is press tool assembly. This is the finished assembly that we have assembled. Now we'll see the complete process of assembling these parts and make this press tool assembly completely. For that we'll start with file, new, and say assembly here. We'll browse for the parts, select the browse feature. First we will call the bottom plate here, say open. So this is the first part. You can see F sign here. It means this part is fixed. So to float this part, I'll right click on the part and say float feature. Now this plate is movable. This sign is also changed here. Now it is showing minus sign here. It means this part is in floating condition. So we will repeat the same thing here. That is coinciding assembly's origin with first part origin so as to match the planes. We'll start with mate option. Select the assembly's origin and first part origin as the first mate. You can see a coincide mate is been applied. Say it OK. Now all the planes of assembly and parts are matched together. Then we'll go for second part. Say insert components. Browse guide pillar. The first mate we are going to apply here is concentric mate as both the shaft and hole are circular in cross section. So select mate. Say concentric, the outer surface of the shaft and surface of the hole. Say it OK. Next we are going to coincide bottom face of guide pillar with bottom face of plate. For that select the mate. Go for bottom faces here. The mate been applied here is coincide. Say it OK. Now as we are having one guide pillar been assembled here, we need to see whether it is fully constrained or not. For that I'll move this guide pillar, I'll zoom and then move. So it is showing that rotational movement is still on here. So to constrain this rotational movement, I'll select mate option. We can do one thing here, that select the guide pillar's planes. Suppose I select here right plane and then select the side face of the plate. You can see this plane is rotated and is parallel now with side face of the plate. So in this way you can lock the rotation of the guide pillar. Now it is not rotating here. You can see if I suppress this mate, this motion is again on here and the part is showing minus sign here. That is, this part is not fully constrained. So again I'll unsuppress this mate. The guide pillar minus sign is removed and it is showing that part is fully constrained now as parallel mate is been applied there between the plane of the guide pillar and face of the plate. Both plane and face of the guide pillar and plate are parallel to each other. That's why the part is not rotating now and it is showing fully defined here. So after defining the part, we'll go for the next option, that is pattern the parts. If you want to individually assemble the part, it will take much time there. For that, I'll go for linear component pattern. For directions, I'll refer these edges. So the linear pattern of assembly and linear pattern of part molding is same only. You just need to select the edges as directions. So I want to pattern this guide pillar in vertical direction and in horizontal direction. For that I have selected this edge and the direction to will be the other edge. You have to select the edge only. Now select the components to pattern. Define the number of entities you require. With this hashtag sign you can define the number of entities and the distance between each entity. The spacing option here. So for direction 1 I'll go for 90 mm distance here and for direction 2 I'll select 190 mm distance. And now you can see the guide pillars are properly patterned here. Say it OK. Now we will call the next part, that is guide bush. So I'll browse that part here. Say guide bush here. So again we'll go for concentricity between guide pillar and guide bush. Select the mate. Select the inner circular face and outer circular face here. You can see concentric mate has been applied. Say it OK. Now I have to apply the distance mate between this upper face of the guide pillar and upper face of guide bush. So for that I'll select mate option. Go for distance mate, select both the faces and apply the required distance. I'll say 20 mm here. If you want to flip the direction of the distance, you can click the flip option here. So this distance will be flipped upwards or downwards. Say it OK. Now we will see whether the part is constrained or not by moving the part. So it is not moving vertically, means the distance made is been applied here, but still the rotation is on here. So to lock this rotation, we can again do that, selecting the mid plane of the guide bush and making parallel with the side face of the plate as we did for guide pillar. Or else we can do, select the guide pillar, say view mates, and here in concentricity, say right click and say lock rotation. So now the rotation is been locked here. You can see this minus sign is also removed. If I again go on the part view mates and unlock the rotation, this part will show under constraint here. You can see the sign. That's why we have made concentricity locked here. Right click and say lock rotation. Close the object. After the guide bush being assembled, again we'll go for pattern option. Select the linear component pattern. In direction we will refer edges, direction 1 and direction 2. Cross check the directions of the arrows and then select the component to pattern. Just provide the number of entities with hashtag sign here as well as distance or spacing between each entity. Say it OK here. Now the last part for the assembly, that is top plate. I'll select the insert components option again. Say browse component, top plate here. Select the mate option. I'll select this face and the circular face here. You can flip the part here and then say it OK. Next I'll make this hole concentric with the guide bush face here. You have to select faces only. It may by default show axis also there, but if you select the axis option, it will take coincide mate. But we will go for concentricity, and for that we have to select circular faces only. Next option here you can see this plate is still moving. Now I want to make coincide this top face of the guide bush with top face of the plate. For that select the mate option, select the required faces. Both the faces are coincide with each other. Say it OK. And now this assembly is also completed here. We'll arrange it in isometric view. You have to press shortcut Ctrl 7 here. So this press tool assembly is completed here. We will see one more option here. I'll delete this part here. Say delete. We will also delete the guide bushes here except the original one. Select all the bushes and say delete directly. Say yes to all. And now instead of pattern you can do one more option here, that is copy with mates. So for copy with mates, I'll select the option. It will ask you to select the component. I'll select the guide bush and then click on this next arrow, and we have applied two mates here, that was concentric and the concentricity was locked, and then distance mate by 20 mm. So we'll select the concentricity and distance command. So we will select the references for concentricity and distance command on the other guide pillars also. For concentricity reference, I'll select this face, and for distance reference, I'll select the upper face. As a hint, it will show the color options here also, so as to refer on these faces. So it is showing purple color on this top face. I'll select this top face only again. Now this part has been copied with mates on the other pillar. I'll say OK and repeat on the next guide pillar, that is selection of the faces. SolidWorks will highlight the required faces on the other part so as to copy with mates. So in purple color it is highlighting here that we have to select this face, and the other face will be the top face. You can see here the color showing. So I'll select this top face again. Say OK. Again repeat the same procedure. For concentric selections here, I'll select this face, and for distance selection, I'll select the top face. So all the guide bushes are copied with mates here. Say it OK, and then you have to say cancel to close the command. Again these guide bushes are being patterned here. So this was the option showing copy with mates command. It is also very important option here. But it is better to copy the parts individually instead of copying 2 or 3 parts together. So I'll suggest don't copy 2 or 3 parts together. Go with individual parts to make copy with mates option work properly. So this was press tool assembly and other options. We'll stop here and continue with the advanced mates in the next lecture. For now I'll say thank you. Please like, share and subscribe the channel.